Hello everyone, I'm Se형 from BMIS lab in the Department of Biomedical Science and Engineering. In this class, I have developed a face movement rehabilitation web application. I will explain the reason why I have built the rehabilitation purpose web app by step by step. So let's get started. So this is a content for my proposal. First, I introduce my research objectives. Second, I show you the concepts of my proposed service. Third, I explain how I developed the service by telling you the story of the making process. And finally, I'll demonstrate how it actually works. Okay, so now I'll tell you my research objectives. There are two reasons I have developed this facial movement rehabilitation service. First, in Korea, cases of facial nerve paralysis are on the rise, with nearly 100,000 patients annually. Second, the number of patients has increased by 42% over the past decade, from 69,000 in 2014 to 20, 98,000 in 2024 in Korea. This surge is attributed to the growing number of chronic disease patients, an aging population with weakened immunity, and increased stress levels. So, since facial nerve paralysis patients are increasing, it is important to make a service that can assist the patients in real life. Okay, so from now on, I introduce the concept of my service. My project is about development of the face movement rehabilitation web application. First, I have gathered real-time video facial movement input with the laptop camera. Second, I have processed gathered data with MediaPipe framework. Third, I have analyzed the numerical key point data processed by MediaPipe with Llama 3. And finally, I have visualized the feedback on PC app developed by myself. Okay, so this is the example usage of MediaPipe, which can detect facial information with mesh function. Next, this is the performance of Llama 3. It seems good compared to other representative models. Uh, so I was also planning to fine-tune Llama 3, but since the result was really satisfying, I did not use any fine-tuning methods for this project. Okay, so in this slide, I'll tell you how I developed the activating PC app. First, I have used Figma as UI UX design because for patients, mental health care with comfortable design is really important. Second, I have built the website by using TypeScript React as frontend and Fast API for backend because it was hard to adopt my design on no-code and low-code platforms. Third, I have used Llama 3 as the facial movement helping agent because of the outstanding performance. Fourth, I have focused on face-detected numerical key points data analysis and giving the solution by comparing experimental data with ground truth data. So finally, I have also made the database page to record the exercise history. Okay, so these are the examples of the designs I have made so far. So I will show you specifically on the later slides. And these are the front-end and back-end implementation examples. So this is front-end and this is back-end. Although it was hard struggling on making the platform with custom programming, it was memorable experience. So, okay, so these are the specific reasons I have made this platform with custom development. First, although it takes time on programming, I can design front-end freely with these frameworks. Second, as I have mentioned before, rehabilitation rehabilitation tests also need design aspect for patient's mind care. And third, I think with custom development, I can easily change web design based on patient's feedback. And finally, I have designed this platform like an app view on web for future research work because I hope it is a good idea to take research on. Okay, so let me introduce how the service works. First, you visit the website and this splash page will come up. Next, before you start the exercise, you will take a picture of yourself for making the ground truth data. And after you take the picture, the platform will try to detect your information. So this is a detecting page, which is also the loading page. And after the detecting process finishes, you will start the actual exercise by clicking this button. So this is the example how you work on with this website. I'll show you the actual demonstration later. So after exercise finishes, the platform will analyze your data. So this is the loading page for Llama 3 analysis. So after waiting, you will get the feedback by the analysis of Llama 3. The comments will be automatically generated with Llama 3 like this. And also, you can compare the previous records all together to get improve your facial muscles stronger. So this is what I actually designed. And it also works same as that. So I'll show you soon. Okay, so this is the end of my introduction about the project. And from now on, I'll demonstrate how the actual platform works. Okay, so this is the main splash page for my uh, web application, and I named it as Healthy Face for health face rehabilitation and exercise uh, framework. So let me start. Okay, so this is if you press this button, you will go to the last page. So I press this button for starting from the start first. Okay, so my face comes out like this and match the match like this. Oh, it's too fast. Okay, and so detecting is completed like this. Okay, and so here detecting was actually uh, completed uh, faster than I expected. So I explain more about here. So media pipe automatically meshes my face and then gather the information automatically in the backend in the front end server actually. Like so everything works on front end and backend works in the last stage. I'll show you later. So let's start to press the exercise. Okay. So look to left side like this. And look at right side like this. And look at offside. Then lastly downside. So since it was too fast, I'll explain more about it. And so I just design the process into four stages: left, right, up, and down. And the reason I only did four stages was that uh, since it's a prototype, I think it will be easier to understand for making it simply. Okay, so exercise finished, and let's press this button to evaluate my stitches. This design is designed by myself. Okay, so is analyzed too fast. So 93%. And my score is a little bit high. And then this recommendation is automatically generated by Llama 3. So let's read it here. Congratulations on achieving an impressive overall accuracy of 90%. And something blah blah. And since I have some time, I'll show you the developer tools for how it works. Oh, sorry for returning Korean, but let me explain. So data are gathered here, and then Llama 3 evaluates the data by itself. And then mm, the records are saved on the backend server. So let's take a look. Yeah, it's 11:07 p.m. and it is automatically saved on Fast API backend server, and score is 93. So yeah, let's try one more. This time I try fast. Okay, so this is the overview. Left, right, up, down. Okay, so 100%. Yeah, it's randomly generating by Llama 3. So very interesting. Okay, and also saved. Okay, so this is actually the end. Let me stop sharing this, and then let's go back to here. Yeah, so this is my end of my demonstration, and thank you for listening together. Although it was short, but I tried my best, and and thank you for listening, and I hope to bore me a lot because I actually worked hard on programming this time. So anyways, I also focused on actually programming doesn't really matter, but like I actually focus on how to design well, so for patients. So I hope you guys are impressed with my design. So thank you for listening, and please vote me a lot. So thank you.